All right, welcome back. Now joining me, very special guest, returning guest of the show, first ever returning guest, Seth Berg.
You're gonna have me back on again, right, Joe?
Sure.
I can be a co-host. Yeah.
Thanks for coming back on. And Seth has his dog Hazel in the background as well.
She heard me talking and she got fed up already.
Which is a very good dog. Okay, so in this section, we're going to talk about the build season and the robot construction and kind of how all that went. And I thought we would start with the most important part of the robot, which is the drivetrain. And I'll pull up some images while we talk about it from that build season. So over here, let's see if I can get the image of a good image of the drivetrain. Here we go.
Yeah, look at that.
Okay, so you want to talk about it a little bit, Seth?
Yeah, so I feel like I should start with we made a mistake here, but and I think this honestly was in part because of the drivetrain work I did 2 summers ago, which we talked about in the last pod, but we decided to go with a robot that could push, could move fast. So this is a 6-wheel drivetrain with the center slightly dropped to allow for quicker turning, maneuverability. We knew that, Joe, I don't know if you've talked about what the game is yet.
I have. We already went through the game.
Great. So we knew that we would want to be able to capture a ball and pivot with some accuracy to target the goal. And so we figured that a drop center would move the axis of rotation closer to the ball. If it was back in the very back, the ball would move considerably in the front, but ideally you really wanted to rotate around the ball. So the closer up your turning radius, or the center of your turning radius was to the ball, the better. And we also went with a shifting gearbox. You can kind of see it in this picture. It was an Andy Mark 2-speed. Yeah, the super shifters. Do they make those anymore?
I don't know. We definitely don't use them anymore.
Fair enough. This gearbox had 2 speeds, a really low gear and a really high gear. I can't remember the exact effective speeds that we had at the end of the day, but one of the things we did was that the gearbox was designed to work with a servo or a pneumatic piston to shift the dog gear back and forth. And we didn't have pneumatics elsewhere on the robot, so we went with the servo, but it really wasn't as effective. It took longer to shift. If it shifted with the teeth of the dog gear not engaged, it didn't work very well.
It struggled to shift on the fly. You have to really stop.
Yeah. And at the end of the day, Joe, this is maybe obvious in retrospect, but the field was split up into these 3 zones with bumps in between. And so there really wasn't like a particularly long range that you could drive at high speeds. And so I was the driver that year, and I was not a particularly good driver. And I basically just kept the robot, whatever. I kept the robot in low gear the whole time. And I think that if we'd gone with a 1-speed, we could have saved weight. It would have removed some complexity of driving, and we would have gone a little bit faster and really maintained all the functionality. We never got into pushing matches, again, in part because of the bumps really split up the field.
Yeah. So I think back in this time of the team, we really tried to avoid pneumatic, especially because in 2008 we had a lot of issues with leaks that cost us matches. So 2009 we didn't have pneumatics. 2010 we didn't. 11.
I'd add, Joe, that at the time you had to have a compressor. You couldn't have reserve tanks, as I remember. So it added a considerable amount of weight.
You could have tanks, but they were very heavy. They were all aluminum. It did add a considerable amount of weight. Yes.
I think it was less common because of the weight.
Yeah. So there were 3. This 2009, 10, 11. We didn't have pneumatics on the robot at all. But I forgot what I was going to say. Oh yes. Do you know if we ever considered, because I wasn't really part of any discussions for the drivetrain. Do you know if you ever considered front traction, back Omni, no center?
No. It's so funny you say that, because I'm sitting here thinking about what I would have done in retrospect, and I think that's exactly what I would have done.
Because you're trying to pivot around the ball. That's
exactly
can't beat that.
Can't beat it.
And actually, the beach bots did that this year.
I'm trying to remember their robot, but it's escaping me.
Yeah, go ahead.
don't know. I think this is probably a case where, like, the season before, I had a drivetrain I wanted to use and it didn't make sense, so we pivoted. And I feel like what happened here was the drivetrain I wanted to use sort of made sense, so I was like, let's do it.
You did something clever here. So this is the old kit chassis from Anymark. It doesn't look like this anymore, but it was a pretty good kit chassis. You put little L bearing blocks to lower the wheel so that we can get over the bumps. And I distinctly recall you cutting out this shape of like the side view of the drivetrain on a piece of paper or cardboard or something, and then you had a cardboard cutout of the bump, and you like showed how it would make its way over without.
I think I did that at John Mead's house. I also have a very clear memory of that. And yeah, we could get over the bump.
Yeah, no problem.
Yeah, that was pretty effective. I don't know if we're jumping ahead, but we did have problems with this drivetrain. I mean, you can almost see it here. If you can't see my mouse, but the wheels that are closer to us, you see the middle wheel has more traction than the front wheel, and the chain, it's this 35 ANSI chain. You can see it's sort of slack here, and it's going to the reduction between the gear in the gearbox and the gear on the wheel is really substantial, and so you don't actually get a good wrap around the smaller, did I say gear? The smaller sprocket.
Yeah.
And
it's a really short distance too.
Yeah, and we didn't have good tension. Yeah, it was a short distance, so we didn't have a good means of tensioning the chain, and so we had issues at Champs where this we popped the chain basically.
Yeah, we didn't really have any issues through New York or Hartford, but yeah, I remember at Champs there were.
I don't know why that was. Why it was so much worse at Champs.
Yeah, I mean that's how it goes sometimes. I just feel like there were probably like 3 matches where it failed, and it really cost us. It was a good robot going into that.
Yeah. I mean, we won New York. It seems to me like with chain, the difference between chain that works and chain that doesn't work can be really small, and so it's plausible that for the first couple of regionals we were really close to that threshold, and something bent a little bit out of shape, something slid, and then we were right in that region where
one of the bearing blocks holes opens up just a hair, the sprocket bends a little bit, or the sprocket bolts bend. Any of those things could happen. One hit could mess that up.
Yeah.
Okay, so let's move on from the drivetrain and start talking about the kicker. So, actually, hold that. Let's talk about the intake first. So here's a picture of the intake. It looks like there is.
It looks pretty raggedy, doesn't it?
Yeah, the tape doesn't help.
No.
Whatever. It'll do the trick. I can see if I have a better one here.
So basically, we talked about this last time, but the idea is, full intake on the front of the. Keep wanting to say printer. Front of the robot. Rollers are good because they are. They're easy to maneuver. You don't have to have good precision. So we built this roller, and we actually used a similar thing, similar polycord. I think the exact same polycord that we did in the robot the year before.
No, we used flat this year. We used round before.
Yeah, sorry, but it was the same material. And we did try round, but it didn't work very well. The idea being that, we sort of had 2 options, right? We could put a switch at the back that sensed when the ball got all the way in and stopped, or this option, which is basically a slip clutch, because the polycord couldn't overcome the torque of the ball stuck inside of the robot. But we kind of made a key mistake here. We were conservative on this one rule that was a pretty important rule. It was that the ball couldn't come over 3 inches within your chassis. And we opted for 2.5 inches because we didn't want to be on the edge, get the competition and be like 3.1 inches and be disqualified. But that 1/2 inch made a big difference on the ball. I mean, I don't know the math off the top of my head, but it made a big 15%? Difference on how much of the ball you could grab. So I think some of the best teams also had a a thing on the bottom that sort of rotated in that captured the ball.
Yeah, so basically
which
two
we
rollers
also did.
hinged it in, which is, I talked about in the last segment, is questionably legal.
It ended up being legal, but we didn't, we didn't think it was at the time.
Yeah, I think I want to just zoom in here so I can explain a little bit more how the slip clutch worked. So there's instead of having like two pulleys and like a timing belt, you had a roller which acted as one pulley and another aluminum roller on the motor. So once the ball was in, this polycord would slip and the motor wouldn't stall, but if the ball came out a little bit, then it would re-engage. So it's really clever implementation. I thought. I don't think this had anything to do with any of the issues we had with the intake.
Joe, sorry, I know it's a bit of an aside, but do you see what's in the back of this picture?
Is it a child?
It's me. It's me with my pants way too down.
Oh, okay.
I was like, those look like an old pair of boxers that I had. What's happening there? Sorry.
That's funny. That's really funny. That's a throwback.
We did have issues where the polycode would wear over time. So I remember looking at that and it turning black on the inside. It's not really the intended. It's not designed to slip. It worked pretty well, but it wasn't the design intended.
Right. I think looking back, there's other means you could have taken to implement that. Other belts we could have played with. But hey,
also there's a lot of good off-the-shelf slip clutches where we could have like bought a few different torques and really gotten to the exact value that we wanted.
Yeah,
we probably could have popped one off a drill and tuned it into exactly where we want, something like that. But I'd imagine weight was a problem.
Yeah, that would have been really cool. Another issue with the intake. So we mentioned, not having it back far enough. Instead of doing like a wall, like actually we can see in our reveal video, there's the prototype here it is, I think. There's a prototype that we made. Had like a 2x4 in the back, an actual wall, but on the actual robot, it's just a shaft at like the halfway point of the ball. So we would sometimes drive up onto the ball.
Yeah, I remember driving up onto the ball.
And that was one of the reasons we had to stay in low gear. I remember like the conversation because I really wanted us to be utilizing that high gear more. But every time we switched, if we had the ball in our possession, we would just drive over it.
Yeah, so there's another flaw here that you might be thinking about. Is that because the center wheel of the drivetrain is dropped, the roller was not a constant distance from the ground. So depending on the direction you were driving, your front or back wheels would be engaged and your roller would be at a different height. So it was designed to acquire well going forward because you wouldn't acquire the ball going backwards. But then if you backed up, the ball sometimes would slip out.
Yeah,
squeezed it out.
And I remember at one of the competitions working with a kid to try to put another axle down low, like maybe it's not powered, but just so we have like a C shape to.
I do remember that.
Pick the ball up a little bit, and we just had nowhere to put it. Like it would get in the way of the kicker, unfortunately.
Joe, what am I looking? Oh, this was the thing that mounted bumpers. I remember the pull pins. I was wondering what this bar in the front was. It's kind of janky.
Yeah, lots of grenade pins. It's so crooked. Okay. Anything else you want to mention about the intake?
I remember it being challenging to get the right material on the intake because again, it wore down.
Mm-hmm.
There were a lot of forces on this ball. Like we were pulling it in, we were driving around with it, we were scraping it on the floor. And I remember at a competition having to retread that with rivets that intake. And the thing worked differently afterwards. It was like a very fine-tuned balance that if you were a little off, it certainly didn't work nearly as well.
I think for something like this, if we were to do something for it today, I think a squishy wheel gives you a lot of play. I mean, alternatively, you could have a spring-loaded roller, but a squishy wheel is a lot easier to make.
And I think I think the clutch is fundamentally a good idea, but you really want a clutch that you can set.
I mean, you can also use a sensor. You can always put like a bar with a limit switch on the back.
Yeah, or you could do back AMF on the roller, but maybe that's a little too.
Uh, but I think, you have a really good point about the center drop messing with this. I mean, we've moved away in recent years from center drop, a lot of it for that reason, because it makes it hard to intake game pieces when you're bouncing around.
It was very in back then. I remember there were a lot of teams that did this.
Well, there was the kit bot on steroids that 1114 put out, which was like, you take the kit bot and you add a shifter to it and you do all these little things to make it better. And a lot of teams copied that.
I remember that.
Let's talk about the kicker.
Man, this thing I just remember how powerful it felt. I don't know exactly how we got to this point in the design, but essentially we probably should have gotten a kicker that pulled back farther. So we had to really put a lot of force on the spring that pulled the kicker forward, because it didn't travel very far, so it needed to accelerate really quickly. But I'm getting into the details. The gist of it was this L bracket that came back and pivoted on a shaft, and then on the other side of the shaft there was a piece of surgical rubber, probably inspired by the 2008 1114 robot, and so it would rotate back with this cam that we'll talk about. Joe's a good gif of it, and then it would spring forward and hit a hard stop, and it worked pretty well, but it just it always felt like the robot was trying to destroy itself every time it kicked.
Yeah, it was so powerful though. We could kick from full field pretty much.
And it was shockingly powerful considering the amount that the foot, was that what we called it? I don't know, the amount that the foot pulled back. It was just like, there was so much surgical rubber there.
Yeah. So let's talk about how we powered this kicker. So if you picture this is part of it, and the kicker would be, it's kind of hard to explain, but you see this thing is suddenly dropping, right? If it's spring loaded and it suddenly drops with a lot of force, you can have a kicker at the end of it that kicks a ball. Yeah,
the shape of the kicker was sort of an L with a, how do I do this with my hands? So no, this is bad. I can't figure it out. It was an L with an opposite, an L leg in the other direction. And so the part that hit the ball was down here, and the part that was up here rode on this cam. And so as the cam rotated, it pushed this part of it back, which cocked the kicker back. And then you can see in this GIF as the ball fell down from the largest part of the cam to the smallest part of the cam, the kicker shot forward. And it fundamentally worked pretty well. I'm trying to remember, Joe, how we sensed when it was right before kicking position. We must have used a limit switch.
Yeah, so I believe used a limit switch that sensed when the kicker was far enough back.
Yeah.
So that's basically, right. If you think of the top of this 6 shape, it would just stop when it was at the top of the 6, and then we could pick up a ball, and then it would rotate a little bit more and kick the ball out. And the really nice thing about this is it only needs to spin in one direction to do its entire motion. So you want to talk about what you added?
Yeah, I will, but actually I just want to give some credit here. So this cam is sort of a weird profile, and it needs to be made out of a strong material. So this was really the only thing I can remember using the real CNC function on the Bridgeport for. So Sam Unger, who I think you're having on later, figured out how to get the Bridgeport to use the CNC software and milled this out of aluminum. But we prototyped it originally with one of at the time, the school's only 3D printer. And so we designed this in CAD. We constrained the kicker to the cam, rotated it, saw that it did the motion we wanted. We printed out the prototype, showed that it worked in real life, but the plastic one wouldn't have survived the forces of the rubber. And so then Sam milled some of those out of aluminum, which were the ones that ended up in the robot. But to get back here, what Joe's talking about, we'll get there in a second. We started, the center of this cam used hex shaft. So the motor drove the hex shaft drove the cam. And originally our intent was that the internal friction in the motor and the profile of the cam would be such that it wouldn't backdrive, but we had to power the kicker so much that when you got to that high point, if you turned the motor off, or even if you held it, it would just roll in the other direction. And it just happened to be the case that the hex shaft we used was 7/16 of an inch. And so I had this, it was like a Christmas gift. I really loved this tool.
I think it was a 1/2 inch hex shaft.
Oh, you know what? Okay, you're right. So it's a 1/2 inch hex shaft. But the Christmas gift I got it was a ratcheting hex wrench with two sides. It was a 7/16 side and a 1/2 inch side. And so the 1/2 inch side fit perfectly on the hex shaft, and it had a really nice built-in ratcheting mechanism. And as Joe said, the camel needs to rotate in one direction. So I chopped my favorite wrench in half. I drilled 2 holes in it, and we mounted it. This was like a pretty last-minute addition onto the side of the robot. 2 bolts through the wrench, and the socket of the wrench around the hex shaft, and it just worked. Like you would bring it up to the position it had to go, and the ratchet would stop it from going back.
Yeah, I mean, those ratchets are rated for like 1,000 pounds.
Yeah, I wonder if there's it's going to be in like some random picture somewhere.
Yeah, I'm trying to find it.
Yeah, dude, I still have that sunflower hat thing at my parents' house.
Me too. I'm at my parents' house, so I have it here. I don't know if I'll be able to find it, but it worked really well, and it's something we implemented in future years. Like we had a cam type mechanism on our 2014 robot, and we put a ratcheting wrench on that. Our climber,
Joe,
yeah.
If you go back to that picture, you can see that the tread on the front is different from the original picture, because we were like fiddling around with it.
Right. Oh wait, you can actually kind of see the ratcheting wrench right here.
You can. Oh, I didn't cut it in half. I guess the 7/16 side was still over there.
Yeah, I think you bolted it all in.
Yeah, that's fine.
So, we put that on our 2017 robot for our climber, and it's just like a really good, simple way to stop something from back driving. It's like, I've even had times where I'm helping out an alliance partner and they're having an issue with a back drive, and I just pull a ratcheting wrench and I slap it onto the robot. Like
I bet you could have even zip tied it on there and it would have worked if you put enough zip ties.
I've done that. And I was like, you should probably bolt this in or hose clamp it or something, but the zip tie will hold this match. But yeah, that was a really terrific idea. It worked very well. With the kicker, though, we had an issue when we first tried it out. I remember we put the robot together and we were trying out the intake and the kicker, and the ball would go like 2 feet. And we're just like, oh God, what a disaster. And I remember
this was late in build season.
Yeah, it was like week 5.5. It was like really at the end.
Yeah, it was because we weren't pulling it back enough.
It just wasn't going back far enough, and we couldn't figure out what was going on. So I remember I'd come in from Stony Brook for the weekend, and I just pulled up a chair, and while people were working, I just sat in the chair and stared at the robot, trying to figure the thing out. And I distinctly remember Mel going, "What are you doing? What are you doing? Did you not help somebody?" I'm like, "I'm trying to think, Mel." And that night, when I come back for the weekends, I would stay at Johnny's house because he lived near the school. And I remember that night, I think he must have been a junior at the time. We stayed up for hours just sketching out different ideas of how to fix this thing. And then we're like, wait, we got this. We figured it out.
I think I had gone home because I was upset. I was like, the robot's not gonna work. Like, we're screwed. Yeah.
And I mean, I was, I hate when this stuff happens, but I also love it because it's a fun puzzle. So Johnny and I just stood up and we drew it up and we're like, this works. This will work. They need we just changed the geometry a little bit, like a little add-on piece to it.
It was a very simple change in the end.
Yeah, it was originally just an L, and we turned it into a.
That's right. That's exactly right.
Yeah, so we came in the next morning. We're like, we have the solution, and I remember Tom was like, sounds right. You should build something to prove. And we're like, oh, we just do the thing. And we're like, fine. And we built a little wood mock-up, and it showed that it traveled further. And we implemented it and it worked great.
Yeah, I remember this sigh of relief when I saw a kick, because it just, at the end, like you said, we had a really powerful kicker, and this was the first time we saw a kick, and it was just like, wow, this suddenly works.
Yeah.
Yeah.
And we also got, CV working, which I actually had forgotten about, but that made everything work really well, is because we had CV working, so it would align
Yeah.
the score.
I remember this. You had stick drive and the buttons on the top. If you press both at the same time, computer vision took over, and there were targets over the goals, and it just aligned, and it worked. It totally worked. We used it in every competition.
Yeah, I think that as things progressed, it got worse. I think a big part of that was it was mounted very haphazardly.
Yeah, that's not how it should usually go.
Yeah. Unfortunately, it's something we still struggle with today.
Oh man, Joe, I'm looking. I know we're gonna get to this in a second, but I'm looking at the little latch mechanism that let the climber arm go up, and I just remember all the problems we had with that pin and servo disengaging.
Okay, so let's talk about the hanger, because I think that,
Yeah.
that's the last part. So this robot was not originally designed to have a hanger.
Yeah. Wow, I remember this hanger. It was really a dangerous hook, wasn't it?
It was, yeah. But as is, StuyPulse tradition, we have 3 days. Let's build a climber on top of this. And this was the original version.
Somebody spearheaded this. It was not me. I'm trying to remember.
It was Sam Crisanto.
Yeah.
A couple of students, and then Emily's dad.
Yeah. Yeah, it was Emily's dad. I remember that.
And they built this thing, and it was just a servo, and it had 2 spring hinges in it. And then it was just a winch, and there was a cleat inside that was from back driving. In here, there was a little cleat that would just catch the rope. And it worked pretty well.
Oh, that was cool. I remember that.
The problem was we were super overweight.
Yeah.
Once they put it on. So then this was version 2. It was cut down. But then I pointed out that it was illegal because you weren't allowed to reach out of a certain cylinder. And we were reaching out.
Oh, and when it did the double flip, the arm reached out the back, right?
Yeah. We might have been able to get away with it. But again, it was one of those things where it's like, what are we going to do if we get called on this?
I remember the cleat was, I was really clever. I don't know if we have a picture, but to describe what a cleat is, it's this thing that you use on sailboats that stops rope from. It's like a ratchet for cord or rope.
Yeah.
These are simple ones we used. Exactly, that was the one we used. So those are spring loaded in, and you can see how you can pull the rope this way, but if you yank it that way, it doesn't go.
Yeah, but throughout the season, something happened, and it just stopped working, or stopped working as well. It stopped catching as well. I think it might have been at Hartford. We put on the winch this Lexan disc with a.
Because we were having trouble with the rope running off the sides.
Yeah, they were having some issues with the cleat. So we basically built in a ratchet into this. There's like a spring-loaded piece of square channel.
Yeah, I remember that.
Not square channel, U channel here. And then this Lexan just has a cut in. It's kind of incredible. We made this in the pit in like an hour.
Yeah. I don't know. It's weird. I can't remember exactly. I'm like both impressed with this, and it feels like we solved a harder problem when clearly the problem was like just making the rope go in the right direction through the cleat that actually worked.
I wasn't really involved in it. I just remember it's like, oh, we just built a ratchet. Cool.
Yeah, that was cool. Oh, wow. You could see the springs. They weren't, you know what? It was at one point surgical rubber, but we ended up with these metal springs. I remember now.
Yeah. So I think one of the blessings in disguise about the issues we had with the kicker at first is like Johnny and I were working on the geometry, but then other people were thinking we needed more force. So it was like they started thinking up ideas, and they came up with these springs that gave us a lot more power.
Mm-hmm.
But we probably could have done it with surgical tubing just fine.
The springs it was hard. I think we just had trouble like keeping the surgical tubing from like pulling apart, right? Like you can't really knot it. You could sort of put like metal rods through it that don't come apart when you pull it, but the forces were too high, as I remember. Yeah. This spring was loud though, right? You remember, because the spring compresses and it can't go shorter than its face length, and it just makes this loud noise.
Yeah. So something I learned that teams did this year that we applied in 2014 was that surgical tubing, when you use it for this kind of application, you generally want to run it through eye bolts. So like an eye bolt on each end. and you run the surgical
Why
tip
is that?
through it. And then to connect it to itself and make it tight, you just use a zip tie. And it works. Like, it holds. Like, you just stretch it super tight, and you tighten the zip tie as much as you can, and it will not fail. We had that on our 2014 robot, and it never slept.
Really? Have you seen those zip tie guns? We use them at the factory sometimes. Yeah, Google it. It's a cool. Can't believe you guys don't have one of these. They're awesome. They're very simple, and they work really well. It's kind of like used for when you're manufacturing a lot of cable harness. You got to make like a zip tie a ton of things. Yeah.
All right, yeah, we're gonna buy this. This is awesome.
Joe, we should do a whole episode on me telling you about fun tools, because I got a whole host of them.
Forget 2010. Let's go. What else you got? This is awesome.
Search pneumatic rivet gun. We have one of these in the office.
Have that.
I love that. It's so much fun to use.
Except we keep losing the fittings. Bad. We didn't have one this year.
And you can look at this. The spring determines how tight you pull the zip tie down.
That's really cool. All right.
All right, let's get back to it.
Order some of that. Yes. Let's get back to the robot. So we ended up adjusting the climber so it looked like this. So basically the top part was already deployed, and there was just one piece here. Really raised our center of gravity. So I really didn't. I think it definitely took away from the robot in some ways there, but it worked.
It also flapped around a lot. I mean, it's just like
it was annoying.
It didn't seem polished.
Yeah, it wasn't polished. But I think the way it really hurt us was we would go. It felt like throughout the season we would just go earlier and earlier to go climb.
Because we had so many problems.
And it's just like, that's not a winning strategy. You can't just be like, we're gonna score these 2 points at the end. Like, you gotta play to the end, to the whistle.
We haven't really talked about how this work though. I mean, we talked about the winch. You can see this rope going all the way up, and then there was basically this friction. I think it was like an IGUS linear bearing and a hook, and so the linear bearing had enough friction in it. I think we might have had a spring-loaded thing underneath it that it would stay there, but when you pulled the winch, it would pop out, latch onto the metal frame, and then start pulling. Oh, I guess you'll see a video of it. It did. You know what? It worked. Totally
it worked well. I just think we started misusing it. Like, I think even like later in the season, we just started, like, even at Hartford, when things weren't going well.
You can see my dad in like every one of these videos. Yeah, I agree. We used it too much, too early.
But that's, something I think, we learned as a team as we progressed, is that you really have to squeeze every ounce of points that you can at any point, because the competitions, you're not going to win it by just being like super.
Yeah, but you know what? We knew that. Like, we saw that in this game. We said, let's make a robot that can navigate the whole field, and let's make a robot that can kick and kick far. We did that, and I think you're right. Like, we added this on, it worked, but we began to rely on it too heavily, where our real bread and butter was being an offensive powerhouse.
Right. So, I almost think that we would have been better off not doing it just because of that. But then that was a learning experience that we applied to future years. Also, this is hilarious. This goes off your dad's camera, I think.
Oh, let's watch it. My dad is the guy kneeling over here with the camera.
Like, it deflects off your dad's camera and into the goal.
Let's watch it. He used to always tell first that he was a member of the press, and so we'd get these official press tags, and then he had access to the field whenever he wanted. I think he probably misses doing that. He really had fun.
He can come.
Yeah, he can.
Follow
him on Instagram.
Yeah, I don't want to go too far into the competition season, because I'm going to be talking about that with Sam. But it really was a great robot. There were places where we definitely could have improved, and a lot of lessons we learned. But it was we made so many leaps and bounds. Like, I'd never heard of what a cam was before. And we were implementing.
Yeah, it was like, at the end of the day, I liked the 2009 robot more. Like, I felt like it was a better robot, but this was a really hard competition. You couldn't build a robot that like sort of kicked, or you could, but it was still hard. And ours just worked.
Yeah. And I was saying in the last video that this is the game where you could have really been successful with a box bot, because you could have just put like mech and wheels and a roller and you would have been pretty good. Just stay in the front field. But we definitely went beyond that.
Yeah.
I think this robot wasn't super simple, but it worked very well. It worked very well.
I'll leave this to Sam, but I hope you talk about Las Gorillas in this.
We talked already in the last video. You can say what you want about that robot.
It's like once every 5 to 10 years you get a robot like that at a competition that just follows the rules but breaks all the rules and is undefeated, unbeatable. I mean, it was, what was it? It was 71 in like 2000 or 99 or something.
2002.
2000. Yeah, it was right. It was Jack's year. And I've watched the videos of it on Einstein so many times. And it was amazing. Fun fact is that 125 had the same idea, but they just didn't implement it very well.
I mentioned that too.
Yeah. They were not very good.
They were not, but they took a risk. You got to give them credit for that.
No, it was. Although, man, I would be. Can you imagine being that team, being like, we were so close to. Also, they didn't win in the end. I remember how I was at Nationals that year.
Mm-hmm.
Of course, I was at Nationals.
Yeah, I was there with you.
Confusing all of my years, but man, that was exciting.
So speaking of the championship, the last thing I want to talk to you about, I just remember this. I'm going to have Betsy on in a later segment, and she's going to talk about kind of our chairman's and dean's list. This was the first year of the dean's list. And Seth, you won the dean's list not only at the New York City Regional, but at the World Championship. And back then you were allowed to have seniors as dean's list. Now you can only have juniors or younger.
That's a good policy. So yeah, I mean, I don't know how much story there is to tell here, but like they told us like with a week left in the season, they're like, surprise, there's this new award. It's a student award. You guys know what the award is. And so Betsy and I wrote submissions for each other. She was the president of marketing. I was the president of engineering. And surprisingly, Betsy is a better writer than me. And so she wrote a better submission for me than I wrote for her. And I won in New York, and I won at Nationals. Actually, I have the trophy up above me. I'm going to turn my video off for a second because I'm wearing my running tights, and I have to reach up above. But I'll grab it. All right, you lost me. Good. Shit.
But it's
this is
really
cool. For the record, since you got me on audio, this is the only award I've ever won. Ever. I've never won any other award.
Well, you won the New York City Regional. You got a medal and everything.
Okay, yeah. I mean, personal award. I had this breaking things. Yeah, I don't know. I don't know what to say. Like it was. I don't think I would have won it in future years when more people were submitted, but they gave this really awesome glass block trophy, which I still have and cherish.
Hey, can you hold it up to the camera? Yeah,
so it uses, I think the way that they do this actually is they use a laser that has a really, how do you describe it? Basically, a laser is not perfectly coherent. It comes in and out, and it has a waist that is where the laser is the most focused. And so I think this laser has a really wide angle, so it doesn't deliver a lot of power to a certain spot for most of it, but it does at a very specific point, and so then they can direct it around and like lays inner bits of this.
I don't think they do that now. It's just certificates.
Really? They don't give these out? These are so cool.
I don't know.
That
was the first year.
Well, whatever.
But yeah, I will always have that. We had the first set, like in the first set of Dean's List winners, we had one.
I was also the first person. I was the first name on the list. I think just for alphabetical reasons.
Yeah.
But at Nationals, my dad was there because he wanted to come take pictures, and he just assumed I wasn't going to win, so he didn't even come to the ceremony.
That's really funny.
But I had to bring this back in the airplane, and I don't know, it didn't fit in my bag or something, and so I had to carry this onto the airplane. And at at security, they're like, what is this? And they gave it like the full bomb swipe down.
That's really funny.
Yeah. But yeah, I really treasure this.
Well,
because it's like up on my shelf.
yeah, it's up with the design award. So, you know,
yeah, okay. But that was for the team. I just took that.
Here we go. This is from the Dean's List ceremony.
Yeah, this is Arnie Duncan, who's very tall, Secretary of Education for Obama. Oh, I remember those shoes too.
Dean Cannon. Yeah, it's pretty cool.
Yeah, it was cool.
All right, I'm gonna let you.
They also gave you this really horribly colored polo, and every year they're like, hey, do you want to come back and like do an event at Champs with all the other winners, but you have to wear this polo, which I definitely don't have anymore because I'm way too large to fit in it. Mm-hmm. But also it's like the ugliest thing ever.
You could ask, they'll probably give you another one.
Yeah, but then I gotta wear it.
Still pretty cool.
Yeah,
it's a cool thing to wear because then people are like, oh, you're cool.
Oh, I feel a little self-conscious, but yeah, no, it's cool. I got 13 more minutes, Joe. What do you want out of me? Then I'm gonna
let you go.
Phone with our factory.
I'm gonna let you go, Seth. Thanks for coming on. Right. This was super fun. Tune in for the rest of this. This is, I think, a really good episode. All right.
I will. And look, I like doing this, so I don't know what else you'd have me on for, like maybe something about other engineering principles or something, but I'm happy to do it.
Yeah, maybe I'll do like some lessons on little things. I'm not sure. Thanks for coming on. I will.
Oh, you know what? I meant to say this last time. No, I'm going to interrupt you. I just want to say everybody's very lucky that Joe Blay is the technology teacher at Stuyvesant. Cologne founded the team, and we would never be where we are without him. But we always knew that Cologne was going to retire, and there were a lot of years where we didn't know what was going to happen. And to not only have somebody succeed Cologne, but somebody who is so passionate about FIRST and a great teacher, I'm sure everybody realizes how lucky they are. But I was and I can speak for like tons of the alumni, how excited they were when they found out that Joe would be teaching at Stuyvesant and leading the robotics team, with a long, long career ahead of him before he retires, and he's got to find somebody to take over for him.
Yeah, hopefully not for a while.
Yeah,
all right.
Not for a while.
Thanks for saying that, Seth. I really appreciate it.
Yeah, dude. I mean it.